Season 1, Episode 5, Common Core, What Too Many People Misunderstand. Now, I'm going to try to not go off on tangents because there's a lot of little pieces here that gets me kind of excited and makes me want to explain further. I'm going to try to stay pretty succinct, but in this episode, we're going to be talking about what Common Core is and what it's not, and hopefully get some of the haters to stop hating. But at the end of it, you still get to have your own opinion, and that's all good. The thing that I really hear about Common Core all the time is it's confusing. It doesn't make sense. It's a lot harder than the other way. Things like that. And to those people, I want to know, what are you talking about? Because have you read the standards? Most of the time, people are not talking about the Common Core standards. They're talking specifically about math, and they're not talking about the Common Core math standards. They're talking about what they have seen as the curriculum that was created to go with those standards. So they're blaming the standards on what publishers are creating. Don't blame the standards. But sometimes don't blame the publishers either. We'll get there. So first I want to talk briefly about English language arts standards, because these are Common Core also. And I don't hear a lot of complaint on this. And I would hope not, because it's actually, the standards are pretty good, in my opinion. They have made an effort to make the English language arts standards cross-disciplinary, meaning the science teacher has to use language arts standards. They are also a language arts teacher. The social studies teacher, history teacher, is also an English language arts teacher, because we want all of these things working together. There's been a lot more switching things up, especially in middle schools and high schools, where they, instead of having a math department, you'll have a set of teachers, a math teacher, a social studies teacher, a science teacher, a language arts teacher, that all together are doing the same unit at the same time. Isn't that amazing? I hear homeschool parents talking about how great it is that they can do things like that. And now they're starting to do that actually in middle schools and high schools. Amazing. The standards are, there are the college and career readiness anchor standards. These are basically like the driving standards behind the then more specific grade-specific standards. So they have these overarching standards that are like the goal of what the smaller standards are supposed to be achieving. There's little steps along the way. Starting in kindergarten, it's a more basic version. We'll look at this a little bit. So you'll have these standards such as read closely to determine what the text says explicitly and to make logical inferences from it. Cite specific textual evidence when writing or speaking to support conclusions drawn from the text. I'm sorry, I know that's a lot to take in. I'm going to break it down a little bit. So this is a reading comprehension standard. It's the first reading comprehension standard under key ideas and details. And this is one of the anchor standards. So it's not specific to a grade, but for K-5, the goal is that by the end of K-5, that kids are able to read closely to determine what the text says explicitly. So it's going to start in kindergarten with just knowing exactly what is written on the page. Who is the story about? Tell me the story that you just heard. Something where we're just repeating some facts. So to determine what the text says explicitly and to make logical inferences from it. So now they have to think, well, it said that he went to the window and got sad. So then you're coming up with an inference. The inference is he was sad because it was raining and he had wanted to go outside because earlier in the story he was talking about going outside to dig. Okay, so they're making inferences. And what I just said, that because earlier it said, this next part, cite specific textual evidence when writing or speaking to support conclusions drawn from the text. So I can support what I'm saying, proving it with something that the text said. The point here is, what you're seeing in this standard and in most of them is an emphasis on thinking deeply, analyzing things, defending your answers. This is the common across the language arts, the math standards. Think critically, defend yourself. Under writing, there's text types and purposes. The first standard is to write arguments to support claims in an analysis of substantive topics or texts using valid reasoning and relevant and sufficient evidence. If you didn't catch all that, you're writing something with valid reasoning and relevant and sufficient evidence. You're arguing a point, and it's not just because I said so, because my dad said so, because I know I'm right. It's what actual evidence do you have? What is the valid reasoning, the relevant and sufficient evidence that you have to prove that you are correct? So you actually have to do digging and gather data, right? It's the deeper thinking. There are also speaking and listening standards. The first one is to prepare for and participate effectively in a range of conversations and collaborations with diverse partners, building on others' ideas. So you have to be listening so that you can build on what they said and expressing their own clearly and persuasively. So based on what someone else said, you're building on that. And maybe building on it in a, well, I don't quite agree with this part because da-da-da. But your argument is based off of what they just said. You're not just having two separate conversations, right? You're having an effective collaborative conversation. That's amazing. Personally, I would hope that everyone is working on this. And the last section of English Language Arts Standards is language. So conventions of standard English, the first standard under this is demonstrate command of the conventions of standard English grammar and usage when writing or speaking. Are you using grammar correctly when you are writing or speaking? So again, this is just something that we are working toward. If you look at the grade specific standards, you'll see where they're working on the easier stuff in kindergarten, building on it in later grades. So all those standards they make sense. They get built upon each other. Whatever you did in kindergarten doesn't just get lost in first grade and then picked up again in fourth grade. Every year builds on what happened the year before. All right. So what people mostly complain about, what I'm seeing, is math. So I want to tell you a couple of things. First, there are two sets of math standards that are Common Core. The first set of standards are these 8 mathematical practices. So listen carefully to these and see if there's anything here that you actually disagree with or think is not something that you would want your child to learn. The first is first mathematical practice, number 1. Make sense of problems and persevere in solving them. Make sense of problems and persevere in solving them. Number 2, reason abstractly and quantitatively. Abstractly would be 3 plus 2 equals 5. You just know that. Quantitatively, 3 plus 2 equals 5, and you're actually showing 3 of something, 2 of something. There's actually a quantity there. Number 3, construct viable arguments and critique the reasoning of others. If you'll notice, this is very similar to the speaking and listening standards for language arts, right? You're coming up with an opinion, an idea about what you think the answer to a math problem is. You're coming up with evidence that that is the right answer. You're listening to someone else present that answer, and then you're critiquing where they might have gone wrong. That's huge. Number 4, model with mathematics. Let's make math hands-on. And pictorial. Models can also be drawings. So that would be a pictorial representation, visual representation that someone is actually creating. The child is actually creating. It's not just being done for them. Number 5, use appropriate tools strategically. So appropriate tools could be a calculator, but it could be a multiplication chart, it could be a number line, it could be the grid paper that you're using. There's a lot of different, it might be a ruler, a variety of tools that you might use to solve a problem. So use those tools strategically. Number 6, attend to precision. This is where you're really making sure that you're being careful about your work. Number 7, look for and make use of structure. Look for and make use of structure. And number 8, look for and express regularity in repeated reasoning. So you're kind of looking for those patterns that are happening in math all the time. And when you see those patterns and you notice them, math becomes a lot easier. And it's actually better and more powerful if we can guide a child to see those patterns for themselves rather than just pointing the pattern out to them and telling them that the pattern exists. All right, and I'm not going to get into too much of that right now. I'm trying really hard to stay out of the tangents. Okay, the very first standard in first grade is under operations and algebraic thinking, which might sound big for first grade. Represent and solve problems involving addition and subtraction. The very first standard says, number 1, this is big. Use addition and subtraction within 20 to solve word problems involving situations of adding to, taking from, putting together, taking apart, and comparing, with unknowns in all positions, e.g., by using objects, drawings, and equations with a symbol for the unknown number to represent the problem. So there's a lot to this standard. This is a huge first grade standard. It's something that I would expect first graders to be working on the entire year, from day 1 to day 180, or however many days are in your school year. You're using addition and subtraction within 20 to solve word problems. And there's a lot of different types of word problems. So you have to be careful that you're actually getting a mixture and you're not just always relying on adding things together or taking something away. But it's actually a matter of, the big one is like comparing is one of the hardest for kids to understand. If you think about, I'll get into an example of that in a minute. So I want to go to a quick example of this type of thing. An easy problem that you could work on. There are 9 apples and 5 oranges. How many pieces of fruit are there? Now, traditional math, what we used to do too often, good teachers never did this, in my opinion. But too often, too many of us, I shouldn't say good teachers never did this. Good teachers knew they shouldn't do this and sometimes did it anyways and then realized. So too many of us, we're just trying to get a child to see, oh, they're adding, you need to write 9 plus 5 and then add them together. Instead of just letting the child figure out what they want to do with it, how they want to solve it. Now, if they actually draw this out and have 9 and 5, especially if they draw this out in a way that shows a group of 10, they will quickly see a way to take one of those oranges, add it to the apples, and now they've got a group of 10 and then 4 more. So they have 1, 10, and 4. Now we're talking about place value to understand that 9 plus 5 is the same as 10 plus 4, and that's 14. I may have lost you there. I'm going to repeat it And I want you to just think through how much deeper this is than just adding on. So knowing, if a child knows 9 plus 5 and they know, okay, 9, 10, 11, 12, 13, 14, right? They've added on 9 plus 5. That's fine to begin with. But what we want is for the child to then use that opportunity to see what else is true. If they lay out the 9 in a tens frame, which is 2 rows of 5, and it's something that usually in kindergarten they become very familiar with. They see it all the time. They know what the tens frame is. They know that that's 10 when it's all the way full. If there's one missing, they start to recognize that one missing means 9. So they automatically know that that's 9 without having to count. That's called subitization, like knowing what a number is without having to count it. So they've got the 9 in the tens frame, and then they've got 5 more. If they can see to take one of those 5 and put it in the tens frame, and maybe they're doing this with actual physical little counters, they can say, oh, I have 10 and 4. And if they've been working on place value, they start to know that 10 and 4 is 1 10 in the tens place and a 4 in the ones place, 14. 1 4 is 14. A 10 and a 4 is 14. So it's not just the number 14 as if it's its own complete thing. It's that 14 is made up of a 10 and a 4. I'm hoping that part is sinking in, that you're understanding that the 10 and the 4 together are making them understand what 14 really is. And they get that by doing it over and over and over in a wide variety of problems. Now, this same problem could have been a different question. There are 9 apples and 5 oranges. How many more apples than oranges are there? This is the comparing problem that I referred to previously. So this is still part of the same standard. How many more apples are there than oranges? This part can be really tricky because they have a hard time understanding the how many more. And then we have to really get them to understand, well, they both have 5, and then there's an extra set of 4 apples that the oranges don't have. It doesn't match up with the oranges, right? And eventually they might figure out that 9 minus 5 equals the 4, but it might start with just lining it up and then looking here. So you're not jumping to telling them how to do it with an algorithm. You're letting them manipulate and figure it out. Now, there's a lot of other math that is involved with this that you might start seeing, things like number bonds and part whole charts. You might be seeing area model. There's different types of division that you might be seeing. You might be seeing number lines, lots of number lines. So all of this is just to help students understand math deeply and really have a good understanding of what those numbers are. Because what used to happen is that kids learned, oh, it says something like how many. I've heard kids say this to me. Well, it says how many, so that's adding. How many isn't adding? How many is, the answer is a number. It does not tell me it's adding. So we're getting away from this word means this operation, and instead, which was teaching to the test, and instead we're getting into what is actually happening. Getting kids to really understand and analyze it. And here's the thing. It is harder and it takes longer initially. But in the past, kids were getting to high school not really understanding what addition, subtraction, multiplication, and division were, not really understanding place value in a way that they could actually use these things in novel situations. And the algebra teachers were pulling their hairs out, going crazy, trying to reteach things to kids who should have known this from kindergarten, first grade. second grade, third grade. They should have known the basics of how math work, but they didn't, and now they're struggling. So a lot of the state standards, the Common Core standards, are coming from that need for kids to be better prepared. And the standard teaching kids how to do 9 plus 5 was not sufficient. And the state testing has changed too, as a reflection of that. State testing used to be all multiple choice. Now, some of it is still multiple choice, but a much smaller percentage. Less than half is multiple choice. There's short answer, where kids have to, and for both math and language arts, short answer, kids have to come up with some kind of short 2 to 3, 4 sentence answer or explanation of their math, demonstration of their math, explanation of why someone else on the test, like another student that they're pretending in the test, where they went wrong in their math. So they're analyzing someone else's math and explaining it. And there's also basically essays for both language arts and math. Now, it's not really an essay for math, but language arts does have like a full 5-paragraph type of essay or large narrative type of essay or piece of writing that is expected. And it's random as to whether or not they're going to get narrative or persuasive or expository. So it's randomly generated at the time of the child taking the test. And what they do is different than what the kid next to them does. So it's all different. But the point I'm making is that all of this testing is not just multiple choice. They actually have to be good at writing. They have to be good at explaining themselves. They have to be able to analyze and be critical. And it's really hard. And it's really stressful. And I highly recommend you investigate the opting out option. I'm not saying the state testing is good. I'm saying I like that it is hard in that, I shouldn't say hard. I like that it is requiring critical thinking. It is requiring explanation. And not all of the answer is were you right or were you wrong. It's how well can you explain yourself. You're getting points for explaining yourself. So that is huge. I personally still hate the state testing because it's very stressful for kids. It doesn't actually teach the child anything. It doesn't particularly help inform instruction very well, although it does to some degree. So it's not like nobody looks at it and does anything about it, but I just find it very stressful for kids. So I'm not a huge fan. But moving on. So what's the real problem with Common Core? My opinion is that people who have issues with Common Core are resistant either because they're looking at poor curriculum that's just confusing and might not spend enough time working through each strategy that they're teaching a child. So that can be a huge problem. Or the teacher or software or whatever that is doing it is not spending enough time with it and should be digging deeper and isn't. So that can be a huge problem. It also looks different, and many of us resist change. So we've decided it's confusing, I don't like it, I'm not doing it. Or it looks different, and many of us fear what we don't understand. So we decide, I don't like it, I'm not doing it. Or it looks different, and it makes a lot of us feel that our own education is being questioned. That's not how I learned it, and I'm doing just fine. I'm a mathematician. Just because you're doing great, and just because you're great at math, doesn't mean that the way you learn math is the best, or that this isn't potentially better. I'm not saying you can't still think that your way isn't better. That's fine, you can have your opinion. I just want you to at least look at the standards before you decide that. Or before you blame the standards. So a lot of it just makes us feel dumb because we don't understand it. We can't teach it to our kids, so I must be dumb. Or this is dumb, and I'd like that answer better, right? People, if you don't understand it, it might make you feel insecure about yourself, and then you start blaming Common Core instead of recognizing that it's actually just that you don't understand it, and you need to learn it also. I've heard a lot of praise from Common Core math, particularly from high school teachers who are seeing that the kids are now becoming better prepared. They're understanding math much better, and there's a lot more growth in math. But we're still working on it. We're a lot closer to having a full, if I remember correctly, this started in 2010. So in the next couple of years, there will be students who have been in Common Core since they were in kindergarten. But really, it's going to take a couple more years beyond that. High school seniors, I'm saying, will have been in Common Core since kindergarten. But it'll take a couple of years beyond that to see what it really is, because the first couple of years of the implementation were a little rough, a little hard, and I know in a lot of districts, certain grade levels did it before others. There was kind of a slow adoption. So I wouldn't expect, it might even take another 10 years before we really see the benefits of the Common Core state standards, if they even stick around that long. If they get replaced, I hope that they get replaced by something better, and that there is not a backslide into dumbing down the education just because parents were feeling dumb or teachers were feeling dumb because they didn't understand it. That just is a need for more support for the parents and teachers, not a need for the math to change. Sometimes people praise certain math curriculums like Singapore math. But if you look at it, it's looking at the same thing. It's trying to get kids to really understand numbers and math. So Singapore math is very similar and related to Common Core math. In fact, my school district had us do a training on Singapore math one year after we were already being trained on Common Core math, because they felt it was, it worked together. Complementary was the word I was looking for. Complementary. Okay. So I hope at the end of this, you are seeing or understanding or believing, or at least willing to go investigate those standards a little bit more and understand that they are about deep critical thinking, explaining to others, defending answers, analyzing. There's just so much great learning that is happening, but it is harder, especially in the younger grades, to get kids to not just do the easy, oh, this is how you count, right? But really looking for those deeper connections, that deeper number sense. It's really powerful. And once again, this episode has gone far longer than I meant for it to. I apologize. This has been Decoding Learning Differences with Kimberly Lavelle, all about Common Core.